Hey everyone, it's Mr. Canfield. Today in Algebra 1, we are doing 4-3, the 4-3 assignment. I guess I should probably get out of the way though. All right, so here we go. You're gonna need something to write on, something to write with, and you're gonna need, you might need a calculator. So make sure you have those things available. Seriously. If you're just clicking through these things, you're wasting your time. You're not gonna be able to do these by hand when it comes to it. So you need to be practicing this stuff by hand. If we were in person, you can bet you would have to be writing stuff down. Please write stuff down. Do yourself a favor. Remember, this remote environment is temporary. So, okay, here we go. Boom. Today we're covering something called elimination, and it's a special technique. So let me copy, paste my, I had all this stuff ready and then I forgot to get my little screen grab tool. Okay, now I have that available. And let me close this there, that way. Okay, less to click on. Here we go. So here's my number one. All right, so elimination. There is a special property that equations have. Let's just show it real quick. Let's say we're gonna look at two baby equations, right? Here's a baby equation. 3 plus 4 equals carry the 5, 7, okay. And 2 plus 7, yeah, sure. 2 plus 7 is equal to 9, right? So there's this thing you can do in equations where if I add them up and you just go vertically, 3 plus 2 is 5. 4 plus 7 is 11. I don't know if you can hear Zena in the background. She's barking at something. 7 plus 9 is 16. If you have two true equations and you add them together, just kind of vertically, you get another true equation. 5 plus 11 is equal to 16. That's true. So there's one little thing that this does not show that we have over here. When there are variables involved, x and x, y and y. If those are not lined up, you can't do this, okay? You have to have this lined up. So we're actually gonna see in our second example that it's not gonna work. So here we go. Oh, huh. I was expecting, so, all right, that's okay. Another thing that we can do, so we have options here. One of them is we can add two equations together. Let's say we have those same two equations. 3 plus 4 is equal to 7, and 2 plus 7 is equal to 9. Check this out. What if I go in and instead of adding, I actually subtract? Well, 3 minus 2 is 1. 4 plus negative 7, or 4 minus 7 is negative 3. So I can write plus negative 3, or I can just write minus 3. And then 7 minus 9 is negative 2. 1 minus 3 is negative 2. That's another true equation. So I can either add, I can subtract. Both of those things are true things that we can do. So it's pretty sweet. And you might be like, well, why would I ever want to do that? Yeah, no, good question. Check this out. If I add these two equations together, this is an example of something that we're not going to do. And I'm going to show you why we're not going to do this. So 9x plus, oh, that's a 1x, right? 9x plus 1x is 10x. And then minus 9y plus minus 9y, which if I was using my calculator, what I would do is I would say negative 9 plus negative 9. Negative 18. Okay, so and I can just write that as minus 18. Y is equal to 9 plus negative 31. Which I think is negative 22. Yep, okay. So this is not a result that we want. When we do, it's called elimination. The idea is that one of our two letters is going to completely disappear. I think I should be a little bit bigger in the corner there. Yeah, there we go. So this is not what we want. What we want, I'll show you. All right. And if you're like, wait, so the whole lesson so far you've shown us, hey, don't do this, don't do this, don't do this. Yeah, I know. It's all for a reason, I promise. I'm going somewhere with this. Instead of adding in this case, what would happen if we went through and subtracted? So 9x minus 1x is 8x. Negative 9y minus negative 9y. What is negative 9 minus negative 9? And notice how I used the two different minus and negative, or they're different things. 0. So the y's actually cancel out to 0, and I don't even write them anymore because they're gone. And the 9 minus negative 31 is the same as 9 plus 31, so we get 40. So here is why we bothered to do this. Over here on the left, you can see 10x minus 18y equal negative 22. It's a true equation, but it's not, there's nothing really helpful about it. It's just, okay, cool, that's something else that's true. This over here, 8x is equal to 40. That's a really easily solvable equation. This is 8 times x is equal to 40, so to solve it, we just divide both sides by 8. There's only one variable left. X is equal to 5. So the thing is, remember, before the solution is 5 is incorrect. And this is because we need an x and a y. So it's super important that we know which one's which. Sometimes when we do elimination, x goes away, sometimes y goes away. In this case, y went away and we found x. So now I have to go back and substitute, and you can pick which one. It doesn't matter, it really doesn't. I'll pick the top one. So I can say 9x minus 9y is equal to 9, and x was 5. So I go in and substitute for that letter. So I'm substituting for x. So now we're going to have to solve this, which when we were doing substitution, usually one of the equations was already solved for us. So this is a little bit more work than we had to do last time. So 9 times 5 is 45 minus 9y is equal to 9. So I'm just going to follow my solving order. And solving order says before you divide, you have to add or subtract stuff. So my goal is to get y by itself. So I got to get rid of the 45. So I'm going to subtract the 45 from both sides. And 9 minus 45, I believe, is negative 36. But I don't know if you saw me earlier checking myself. There's no shame in just double checking. I would so much rather be correct and had to use my calculator than be wrong and use my head. All right, negative 9y is equal to negative 36. Notice how it was minus 9y. The minus comes down as a negative with the 9 now. And now we can divide by negative 9, divide by negative 9. Remember, you always divide by the number that is on the variable. If it's negative 1, you divide by negative 1. If it's 153, you divide by 153. You divide by whatever it is, positive or negative. Over here, it cancels, and we're going to get y is equal to 4, and that I'm confident of. So my solution then, I got 4 and I got 5, and I'm going to type this in wrong just for you. Just for you. I'm going to type, I got 5 and I got 4. I meant to type it in wrong. I really did. I was like, okay, I got 4, I got 5. Oh wait, 4 was, oh dear. Right, x goes first, y goes second. Oh, hey, I'm gonna make a mistake. Nope, I'm fantastic. All right, so that is, that's basic elimination, and you can either add or subtract, and that's gonna take care of a lot of situations, but only when the numbers match. So let's look at our next one. All right, oof, lots of text here, but we will talk about this really quick. So, copy. Oh wait, I'm supposed to, what, 125? That's my zoom. All right, so check it. X is equal to 6y, 48 is equal to 2x plus 2y. Here's the thing. If you try to add this one, well, y and y are over each other. Like, it's a little bit spaced out, but we would be like 6 plus y. But this is 6 and 2x. Those are not both x's. They're not over each other. And then x and 48, it's not a number over a number. So since it's not lined up right, we can't do elimination. And this is a great time to do substitution because x is solved for, and it's solved for all this junk, so I can go and I can plug it in there. So this is set up to do substitution. There's a way to manipulate it and turn it into an elimination problem. And that's one of the big things, is that this method called elimination is a method. It's a way to do it that sometimes it's better to do it this way. Sometimes it's better to do it that way. It depends on the situation. And you can always do either one, but sometimes one way requires more setup than the other way. All right, let's see. So the reason this is so good is because x is already solved for and you can stuff it in. So let's see. The first equation is already solved for x, right? So 6 plus y can be substituted for x in the second equation. Yeah, okay. Also, any English nerds out there, for is a preposition, and it's not actually that important, and it's not even a rule. But some people will think less of you for ending a sentence with a preposition. It's a little joke. It's one of those, like, it's not super proper to end a sentence with a preposition. So I'm just like, oh, I'm better than whoever wrote this problem. Like, but it's not actually true because it doesn't actually matter. Okay. Cool. We'll do this one. This is a really good one for me to do. And then, like I've done before, I'm going to cut the video there. And in part 2, we're going to see the more complicated type. And that way you'll have 2 shorter videos to hopefully help you complete the assignment. Okay. So this time, do I want to add or do I want to subtract? And so what I'm going to do is I'm just going to look and say, okay, 10 plus 2 or 10 minus 2, neither way are they going to cancel out. But here, y and y, wait, these are 1y's, right? So 1y plus negative 1y or 1y minus negative 1y. And if you're not sure, literally, you can go 1 plus negative 1. Oh, that's 0. 1 minus negative 1, that's 2. Okay, so plus is what's going to cancel that. So that lets me know I can add it. And if you're like, Mr. Canfield, the problem says use the addition method. Yeah, I know. It's not always going to tell you, though. So I want you to be able to discern what the right way to do it is. All right, 10x plus 2x, 12x. The y's, and then 6 plus 6, 12. 12x is equal to 12. Just divide both sides by my coefficient, by the number in front. X is equal to, I won! All right, so we got x. So, like, you know, if you want, you'd be like, all right, x, that's that. Okay, I know that. I just got to find the y coordinate. You get to pick which one you do. It doesn't matter. I'm going to do the first one because I can. You can do the second one because you can. It doesn't matter. That's the whole point, is that it has to, this x and this y have to work in both equations. So 10 times 1 plus 1y is equal to 6. You know, a lot of people will write the 1y there. So 10 times 1 is just 10. So it's 10 plus 1y is equal to 6. I'm going to subtract 10 from both sides. 6 minus 10 is equal to -4. Here's the thing. Some people will write the 1, and then at the end, they'll divide by 1. And it makes me sad that they do that because they're making more work for themselves. But it works. It's not wrong. And we could say they're just applying the solving algorithm. They're just they know that every time you divide by that number that's on the y. And sure, it's a little shameful if you think about it, like whenever we divide by 1, nothing happens. Dividing by 1 doesn't change anything. But there's nothing wrong. And there's nothing inherently wrong about doing that. So I got y is equal to -4. So I got 1 comma -4. So I can go into Savas, and I can type 1 comma -4, close my parentheses, and that should be another. I got fantastic. All right, cool. Fantastic. Okay, so that's the basics. It's not going to work every time. And here, so for me, my first example where it doesn't work is number 5. I'm guessing it'll work there. Okay, so I'll see you in the next video for the next part. In 3,